All right, so we know that when you have a polynomial expression, you can always factor that polynomial expression, right? So for example, if you have something like x squared plus 5x plus 6, is it possible to factor that? Yes. How do we factor that? Right, it's x plus 3 and x plus 2. So what we do in this case is, this is a quadratic expression, right? It's a quadratic function. When I factor it, I write it in linear factors. So I basically convert it into simpler expressions from which this came. Do you see what I'm talking about? So I reduce the polynomial expression into simpler linear expressions. All right? Now, when I multiply these, what am I supposed to get back? When I multiply these two, I get the quadratic equation back. Okay? Now, we're going to do the same thing now for rational expressions, a fraction. Okay? So here we have a rational function. What we can do with rational functions is we can write it as a sum of simpler rational functions. So if I have this complicated fraction, I can break it down into the simpler fractions from where that came. That's what we're going to be doing here. Now, these simpler rational functions have real constants as their numerators, and their denominators are linear factors or a quadratic factor. We'll come to that. Okay, look at this fraction here. This fraction is the more complicated form. This is a rational expression. We decomposed it, that's what we say. We decomposed it into two simpler fractions, which when added together, give you this main fraction back. So that's what we're going to do today. Until now, you know if you're given these two equations, the two smaller fractions, you know how to add them to get this. Well, now we're going to go backwards. And what we call this process is decomposing into partial fractions. All right, so let's do this example. It's actually the same one as above, as here. So let's just do this one. What you have to do first is you have to factor the denominator. All right, so let's factor the denominator. And when we do that, what do we have? The numerator is x plus 13. How does the denominator factor? X minus 5, x plus 4. Okay? Now, I want to decompose that into two smaller fractions from where this came. Okay? All right, so let's do that. I'm going to write the main fraction here. Equals, now, how many elements are in the numerator here? I'm sorry, in the denominator. How many terms, how many elements? There are two terms. You have an x minus 5, you have an x plus 4. You have two terms here. That means you need two fractions, one and another one. Now, each of the fractions gets one of these denominators. So the first one gets the x minus 5 as its denominator. The next one gets the x plus 4 as its denominator. And what about the numerators? Each one of them gets a constant. And it's just convention that we use capital A, B, C, D, E for these constants. So the first one gets an A, the next one gets a B. If there was a third one, it would be a C, and so on. You just run down the alphabet. Okay, now what we're going to do is we're going to multiply through by the common denominator. All right, the common denominator is x minus 5, x plus 4. I multiply every single term by that one. Okay, In the first one on the left, both of them cancel, right? Everything cancels. Here, the x minus 5 cancels with the x minus 5. Here, the x plus 4 cancels with the x plus 4. So let's just see what we have left. I have an x plus 13 here equals a times x plus 4 plus b times x minus 5. Okay? Now, what I want to do is I want to come up with a number that will eliminate one of these terms here, either the a or the b, right? So suppose I want to eliminate the b. What number can I plug into x here in order to make that parenthesis 0? 5. So I just plug in x equals 5, and that's the reason why I picked x equals 5. I just picked one of the parentheses to get rid of, and then you choose the number that will make that 0. But when you pick your x, you have to plug it into all of the x's. So it's 5 plus 13 is equal to a times 5 plus 4 plus b times 5 minus 5. So what's 5 minus 5? 0. What's 0 times b? 0. So that goes away entirely. So what do I have left? 18 is equal to 9 times a. Okay, so what's a? 2. Now I do the same thing, but I want to get rid of the other parenthesis. Now I want to get rid of the x plus 4. What can I plug in here to get rid of that? Negative 4. So I make x negative 4, and I say negative 4 plus 13 is equal to a negative 4 plus 4 plus b negative 4 minus 5. All right, the a term now goes away entirely. So I have 9 is equal to negative 9b, right? So what's b equal to? 1. All right, and now I'm essentially done. What I have to do now is I have to put a and b back into my fractions here, all right? So I have a over x minus 5, so that's 2 over x minus 5 plus negative 1 over x plus 4. Especially when, okay, so when you have the numerator as a negative number, it's better to write it like this. So we have 2 over x minus 5 minus 1 over x plus 4. And that's your answer. That's it. You're done. Yeah. So if you add or subtract those, if you subtract these equations, you get the main fraction back. Okay? All right. So when it comes to decomposing, there are several cases. The first case, which is what we did here, is when your denominator gives you linear factors. So when we factored this denominator, the x minus 5 and the x plus 4, these are linear, right? They each have an exponent of 1. All right. So that's the first case, is when the denominator has linear factors. Now, what if, though, this is still part of the first case, it's like an exception to that rule, or a subset of that rule. What if you have an improper fraction? An improper fraction is when the degree of the numerator, okay, is either the same or greater than the degree of the denominator. Okay? So look at this one. What's the degree of the numerator? Here, a 2. What's the degree of the denominator? 2. This is an improper fraction. If the exponent on top is equal to or greater, that's an improper fraction. When you have that, guess what you have to do? Long division. Okay? No. So let's do long division on this one. The denominator is the divisor. All right, so here we go with long division. We have the x squared minus x here. Now the reason why we can't do synthetic is because the denominator has a degree higher than 1. And here we have negative 2x squared plus 9x minus 4. All right, so here's a reminder on how we do long division. Now, these aren't going to be, very, very long for the partial fractions. All right, so what we do is this. You take the first term here and the first term here, and you divide them. So negative 2x squared over x squared is negative 2. Now you multiply the entire dividend here, the entire divisor here by negative 2. So you're going to get negative 2x squared. Negative 2 times negative x is positive 2x. Now what you're going to do is you're going to subtract these from each other. This minus that goes away. 9x minus 2x gives you 7x, and you bring down another one, minus 4. 9x minus 2x. 9x minus negative 2x minus negative 2x is 0. It's minus minus. So this is it. Now we're done. We know we're done because the exponent here is less than the exponent here. So we know we're done. So what did we get for this finally? This is equal to negative 2, that's the quotient, plus the remainder over what was our denominator? X squared minus x. Okay? Now what we have to do is we have to decompose this fraction. Okay, so we're going to set the negative 2 aside for a minute, and we're just going to work with that fraction. So we have 7x minus 4 over x squared minus x. What happens when I factor that denominator? So this is really x times x minus 1 equal to, okay? How many terms do I have in the denominator now? I have the x and the x minus 1, so that's 2. That means I'm going to need 2 fractions again. The first gets an x, the second gets an x minus 1. Yeah. The negative 2 didn't go away. I'm just decomposing, the fraction. All right. The first one gets an a, the second one gets a b. Now I multiply by the common denominator. X minus 1, x minus 1, x minus 1. Everything here goes away. Only the x's go away, and just the x minus 1's go away here. So what I have is 7x minus 4, ax minus 1, bx. All right? All right, now I'm going to do the same thing. What number can I choose to make b go away? 0. And by the way, you don't have to do b first. It's totally your choice. So let's pick x equals 0. And I get 7 times 0 minus 4 equals a times 0 minus 1 plus b times 0. That is just 0, so it goes away. Negative 4 equals negative a, so what's a? 4. All right. What can I choose to make this one go away, the a go away? 1. So let's put in x equals 1. 7 times 1 minus 4 is equal to a times 1 minus 1 plus b times 1. So this is 3 is equal to b, and b is 3. All right? That means my fraction is a over x, which is 4 over x, plus b, which is 3 over x minus 1, right? That's just the fraction. Don't forget that I had the negative 2 in front here. I just tack that on at the very end. I mean, at the very end of the problem, but at the beginning of the solution. So it's negative 2 plus all of that. And that is my final answer. Okay? So you have to have that negative 2 there. You have to do the synthetic division. All right? I mean the long division. What do you mean? Oh, you just can't because that doesn't divide. Right? Like when you're doing division and when your remainder is less than the number on the left, then you can't go anymore, right? Because it doesn't go in there anymore. Right? All right. So that was if you had a denominator with just linear factors. Now, this is the second case now. What if you have a denominator with repeated linear factors? Okay? A denominator with repeated linear factors. In that case, you have to do as many fractions as your exponent. So for example, look at this one here. The denominator has an x cubed. Okay? Because it's got an x cubed, how many x's are there? 3. You need 3 fractions. 1 for the x, 1 for an x squared, 1 for an x cubed. So basically, whatever your exponent here is, you start with that term with an exponent 1, then 2, then 3, until you reach that point. Look at this next one. You have x minus 1 squared, right? So you need 1 for an x minus 1 to the 1, and then an x minus 1 to the 2 until you reach that point. What if you had an x to the 4? What would you have? You would have 4 of them. X squared, x cubed, x to the 4. Okay. So let's do this one. Let's first factor this. So you factor out an x, and you get x squared minus 4x plus 4. And how do you factor that? So this is x times x minus 2 squared. All right. So let's do this next one. So we have here 3x squared minus 5x plus 4 x minus 2 squared. You have an x, right? And now for the x minus 2, you're going to need 2 of them. Because the exponent here is a 2, you need one with an exponent of 1 and then exponent of 2. So you always start with an exponent of 1 and keep going up until you reach the exponent that's here. Okay, this gets an A, this gets a B, this gets a C. And the rest is the same. We multiply by the common denominator, which is what? X times x minus 2 squared. All right, here the x minus 2 squares go away. In the middle one, 1x minus 2 cancels with 1x minus 2. Everything goes away here. Oh, and I forgot this. The x's go away. All right, so let's see what we have left at the end of the day. On the left side, all I have is my numerator equals a x minus 2 squared plus bx x minus 2 plus cx. Oh my. Okay, so guess what you have to do now? FOIL, distribute, multiply, simplify. So let's do that. Maybe I won't. Which one? Because on top here you have 2x minus 2, but here you have 1. So one of it goes away with the other one. Okay. All right, so here we have 3x squared minus 5x plus 4. This is a. All right, we're going to FOIL this one. X squared minus 4x plus 4 plus distribute the bx. Bx squared minus 2bx plus cx. Now I'm going to distribute the a. So we get ax squared minus 4ax plus 4. Okay? 4a. Yes. Okay, now here's what I'm going to do. I'm now going to group these by their exponents. What does that mean? You want to collect all of the ones with the x squares and write like terms, okay? Collect all the ones with the x squares, all the ones with the x's, all the ones with just constants. So this is going to stay the same. Now, let's collect all the ones with the x squares. You have this one and this one, so it's ax squared plus bx squared. I'm just rearranging now, okay? And then you have the x's, negative 4ax, negative 2bx, and cx. And then you have, what else do you have? Just the 4a. Okay? Now, from the red terms, can I factor anything out? I can factor out an x squared, and I get a plus b times x squared. Okay? From the other one, can I factor anything out? Just an x. So, just a 2. So, plus, I have negative 4a minus 2b plus c times x. And the other one, I can't factor anything out. All right, and this is all equal to this business. Now comes the fun part. Look at the x squared terms here and here, okay? In the purple, what is the coefficient of the x squared? 3. Here, what is the coefficient of the x squared? A plus b. Okay? So the number in front of the x squared here is a 3. The number in front of the x squared here is an a plus b. So you say 3 equals a plus b. Okay? The next one. What's the number in front of the x on the left? Here it's negative 5. Here it's that mess. So negative 5 is equal to negative 4a minus 2b plus c. Okay? Okay, I'll pick up on this on Tuesday. For homework though, do the first 3, 1, 5, and 7. Okay? So that's due for homework for Tuesday, 1, 5, and 7. Wednesday. All right, so that's due Wednesday.